remote code execution with social engineering. Now that probably sounds like a common scenario for most cases, and it is indeed. In this scenario, in the premise that we're building here, is we're going to look at a specific scenario that involves an end user, a victim, remote worker, somebody working from home, for example, connecting to a Wi-Fi access point, and with intention of getting internet access, right? Maybe they want to start a VPN and access the corporate network. In this case, what we're basically going to explore is how can we get remote code execution on a host with the use of a compromised access point. And how that's going to happen is basically we're going to leverage a specific feature or capabilities inside a VPN, especially enterprise VPNs. More on that bit later. But what we're going to do is look at the whole captive portal scenario, or the behavior, or mimic captive portal behavior. So in other words, force a VPN that was configured to mitigate captive portals, and use that behavior against the VPN to get sort of kind of code execution on the box with assistance from the end user. So what this entails with captive portals and how captive portals work, just to get that going, is our scenario is going to start off with the user, the host, trying to get internet access once it's joined the access point. And all operating systems, modern operating systems, from mobile to your Windows and Mac OS, behave in this way, where they actually, upon getting a DHCP address assigned, they will probe for a specific URL. And when they get a specific response, or a non-invasive response, they assume there's internet access, or they're not behind a intranet and not locked in. So this is depicted in here, where you can see the host starts up, get access to the Wi-Fi, probes for internet. But if there's a captive portal in the way, it looks a bit different. The captive portal will take that HTTP traffic and redirect it to itself. It'll block all other internet traffic, all other traffic bound for the internet, but it'll specifically redirect HTTP traffic to the captive portal web site, and then forcing the end user to interact with it. The operating system will detect that somebody's tampering with this HTTP probe request, and it'll assume that there's a captive portal in the way, and it'll launch the appropriate browser to take care of this. Now, in our scenario, what we're going to do is we're going to actually fiddle with this behavior to specifically target a VPN that has captive portal mitigation enabled. And what we're going to do is basically we have our premise of a captive compromised access point under the control of an attacker, and this attacker sits somewhere perhaps on the same local LAN, maybe could be even be remotely. But in our scenario, it's all going to be happening locally. And the whole idea is the attacker is going to get an interactive shell on that victim's machine. So just to demonstrate, we can do something like this. Tools that we're going to need are the following. You'll see there's a couple listed here, but it's not that complicated for now. We're going to just focus on our hosting environment. We've got a virtual host, which is our Windows host sitting inside a virtual machine, and it has actual physical access to a real access point using a pass-through USB, a Wi-Fi adapter, and we have a physical host for our attacker, which is in this case a Kali Linux box that sits outside and also connected to the same Wi-Fi access point. And this Wi-Fi access point is under the control of this so-called attacker, and we've modified the behavior of this captive portal to play on the whole social engineering aspect, where we've actually trying to solicit certain behavior, which we'll touch on later. And you can just see how this is depicted from a just explanation point of view, captive portal Wi-Fi access point type of environment with a victim inside our virtual machine and our attacker observing and interacting where necessary. Next, well, for this whole premise to work, we're going to need a VPN with a captive portal mini browser to mitigate interacting with captive portals websites. And it basically is something that is defined through this wireless broadband alliance process that speaks to how captive portal mini browsers should behave, or actually just records it anyway. But this is a very good generic flow for Android, Apple devices, as well as Windows operating systems. And you'll see if we start from the left hand side, working our way all the way to the right, I'm only going to flow the captive portal side, but basically once the access point assigns a DHCP address on the left hand side, our host then progress to, like I said earlier, checking if there's a connectivity. Once it detects that there is connectivity and it detects that it's in a captive state, it would then launch the captive portal browser. Now in our case, we are using a VPN that has the captive portal mini browser, a proprietary browser built into the VPN. It will take over and handle the interaction with the captive portal. It will eventually get into the captive portal presentation state. In this state is where this captive portal mini browser allows the user to interface with the captive portal and do whatever it is required. A normal captive portal. In our case, we've primed that interaction to solicit certain action from the user, playing on the social engineering aspect where we require the user to run and to download and execute a HTML application file. But eventually the idea is that the captive portal mini browser will detect that the user is reaching has passed it and now have internet access. So this is something you can explore on that URL at the bottom, but this is a standard flow for most captive portal mini browsers. And it's quite well documented. As we can see here on Microsoft's explanation of how their state detection, captive state detection works. It probes using a certain predefined host name as well as URL, and then goes through that same motion I just spoke about, and trying to figure out where and what to do. All right, so how's this going to work from a VPN mitigation point of view? Same behavior as with described in the beginning. Even our VPN detects the network becoming available once we've associated with a Wi-Fi access point. It'll also try and establish its tunnel. It'll realize there's some shenanigans going afoot, and it would then start doing its diagnostics approach. Is there a captive portal in here? Yes, there's a captive portal here, and we will see it, same type of scenario. But at this stage, when it detects this redirect, it will pop up its captive portal mini browser. A VPN that has captive portal mitigation enabled will force its captive portal mini browser, its proprietary browser, to be the only browser that can interact with that captive portal. Now, in this scenario, there's some devices require additional lockdown features to completely block all attempted network traffic. But in this case, with our scenario, we've only focused on the captive portal mini browser. We haven't locked it down completely, so it'll enable additional connectivity still to try and reach the internet, which we're going to take advantage of. Next, our reverse shell, or our code that's going to execute on that host. So without having to do any or exploit any 0 days or any vulnerabilities, we are purely going to exploit features and functionality of the captive portal mini browser, and use that with some help of the user to get code execution. The final reverse shell what we're going to do is we're going to use a WebSocket based reverse shell with a command and control style interface for the client to the server, and that's going to that's implemented in this case through Rust, which is just a programming language, but it'll be our final payload that's getting deployed at our on our victim. But to get this client deployed on our victim side, we using certain shenanigans, certain behaviors and features of the Captive Portal mini browser. So let's walk us through that behavior. You'll see to get this attacker access onto the host, there are 5 phases that we're going to go through. And these 5 phases are dependent on certain steps being followed once the Captive Portal mini browser kicks in. All right, so we're going to use a feature that's currently available in Windows 10, which is called MS Build, Microsoft Build, which is a kind of sort of development tool that's standard feature inside Microsoft Windows. Why it's there, it's not really sure, but it's quite a powerful feature, and certain attackers are known to be using this as a what they call a living of the land or a lol bin to facilitate lateral movement, privilege escalation, etc. So we're going to do the same to emulate that behavior, and we're going to start off with the Captive Portal mini browser, dropping this MS build file as an XML file, which is a meta file that explains how to compile certain code, right? So we're going to drop with the intention of dropping code on our victim's environment that's not compiled yet, and we can actually compile it on that host. In this case, we've embedded this MS build file in an iframe of one of the documents, HTML documents, that's being downloaded by the Captive Portal mini browser. Now, at this point, it becomes important to note that this Captive Portal mini browser that we're targeting, we know it uses an embedded version of Internet Explorer 11, which is also loaded from Windows 10. So we thought that we were rid of IE 11, but it's still somewhere in the bowels of Windows 10, and this Captive Portal mini browser is actually embedding that as its browser. And it's got certain, IE11's got certain behaviors that we know are flawed because it's got a very predictable cache, browser cache. So what we're going to do is serve the MS build file through our Captive Portal mini browser. It's just going to download this XML file and dump it in the cache on the disk of the victim's machine. And then once this phase 2 is the critical phase in the attack. If the user is required to click on a link, and if that user doesn't click and run that link, the whole attack, falls on its face. But with the way that we've primed the attackers, it seems kind of legit, and maybe somebody clicks and runs the link. And this is going to download a Microsoft HTML file or HTA file. We've seen this also in some attacks because it's an executable file. Automatically you click it and then the mshta.exe file runs this, and you can script the content inside this HTML application, such as VBScript. In our case, we have a script that will go and find our MS build file in this predictable cache of Internet Explorer 11. And once it's found our build file, it will invoke msbuild.exe on it, and we will have our phase 3. Right? So now we have a .NET in-memory loader because it was just text at that point. And once our build file is now created this, quite a powerful loader for us, it will go and fetch a third loader. If I want to say third loader, is the phase 3 has 2 loaders basically, but we're going to fetch another .NET loader which actually will execute our go fetch and execute our Rust reverse shell, which then makes for phase 4 complete, right? And at this point, we've got code execution effectively on that box. And all that remains now is that for phase 4 to complete is that Rust reverse shell execute completely and establish a connection back to our attacker's waiting process. So we have now complete access to that host, and we are running in the context of that user that executed that HTA application And through all these hoops that we've jumped, we can now interact with that host, right? And if the VPN established after this, hey, we got now same access that the user has onto that VPN, and we can get into the corporate network potentially through that. All right, so how does that play out now in real life if we look at it from a demo point of view? All right, so we have our victim that's going to join a access point, and we see we've already gotten our VPN ready to go. All that's required is the user needs to join the captive portal or an access point for that matter. Basically what's happening, the captive portal will, or the compromised access point will behave like a captive portal. And here we see and once it's connected to the Wi-Fi, the VPN's captive portal mini browser will get presented because it detected there's some sort of interference and it thinks it's a captive portal. And hey presto, it loads the captive portal page that we, inserted. And here we're trying to fake a corporate policy update. These things are a thing of beauty, and captive and corporate policy updates for these type of things happen. So once again, we're playing on the hopes that this is not a very technical person, and that they will fall for our ruse and click up and download the policy, and we say hopefully they click run. And if they click run, right, you'll see briefly there's a flash in the background of a HTA, MS HTA running. But most importantly, if you pay attention now, we've allowed this HTA icon to reside on this taskbar. Now, HTA applications are quite rich and you can do quite a lot of things. We've actually hidden the window from here, but we've allowed the icon to remain. We could even hide that icon in the background so that you wouldn't know that this MS HTA is a resident. And what we can see now is when we look at it from our attacker point of view, here we'll see we've prepared the web server on the left hand side, and we have our you'll also notice that there are a couple of files there that we're going to serve. We're most interested in the client.exe and the console app1.exe, and on the right we're going to have our actual reverse shell server sitting and waiting for a session to come in. And this is just a WebSocket server sitting there waiting on port 80. And moving along, we'll see that at some point, if you recall, that the user clicked that HTA link, or that link that downloaded the HTA, and if it ran, and our process will now download you'll see it'll hit our web server, and it'll download the console app, and it'll download the client.exe file. And these speak to phase 3, right? Phase 3 is complete, and it's setting up phase 4, which then results in our phase 5 hitting our server. Right now we have code execution on that host, and there we go. Hey presto, we have a directory listing on that host, and you'll see we're actually sitting inside the cache of IE11, and you'll notice there's also the build file that we served through this policy HTA file. And now we can do what we want on this host, right? We can piggyback, we can write, we can do whatever we want. This demonstrates that through a bit of social engineering and some basic feature abuse on a captive portal mitigation feature of a security product, we can actually gain code execution in the absence of other controls. I hope this was insightful, and I hope you found this educational. Thank you for joining us.